This is Professor Stephen Litch in the Principles of Economics talking about industrial organization. This unit talks about the behavior of firms in general and then also how firms behave in different specific types of markets. There are several general types of markets, and what distinguishes one market from another is mostly determined by something on the supply side. One model we have for a market is a competitive market. A competitive market has many sellers of an identical product. So those are the two key features. Again, there are many sellers and they all sell the same product. So I think of the market for gasoline. I can drive down a street in town and see one gas station after another. All of them are selling essentially the same product. Or the market for milk, or the market for corn. You could drive down a country road around here and see one corn farm after another, after another, after another. So again, this fits the general pattern of many sellers of an identical product. Together, these two things imply that all firms will be price takers. In other words, the sellers do not have the ability to set the price on their own, and they must simply accept whatever price the market is offering. Think of a road that has a line of gas stations, one after the next along it. If all of the gas stations are charging the same price for gasoline and they have as many customers as they want to sell to, then if one gas station were to raise its price higher than the neighboring gas stations, nobody would go there. That gas station would lose all its customers if it's charging a higher price than others who have an identical product. On the flip side, there's no reason why one gas station would want to lower its price any lower than its competitors. As long as it has plenty of customers coming and it can sell all the product it has, it isn't going to want to reduce the price because that just cuts into the profits. Okay, so competitive market, again, many buyers of an identical product. That implies that every firm will be a price taker. A final important characteristic of a competitive market in the long run is that there is free entry and exit of firms into the industry. That's different from, for example, monopoly, where there is a single firm in the business and no one else is allowed to enter the market. Okay, so the characteristics of a monopoly, again, there's a single seller of a unique product. This company is the one and only company that sells some good. That allows the monopolists to set their own price. They can determine what price they want. There's a trade-off between the price they set and how much people will buy, but they can raise the price, again, knowing there's a trade-off that fewer people will purchase their goods if they raise the price. The market for diamonds is, in fact, a good example of a monopoly market. For many, many years, the diamond market has been controlled essentially by one business. The De Beers Corporation has mined and sold about 80% of the diamonds in the world. So it has a near monopoly on the diamond industry. De Beers has put a lot of effort into maintaining the price of diamonds. In fact, diamonds are not especially rare or as valuable as you might think. The thing is, the diamonds in the world are concentrated in just a few mines, and the De Beers Corporation mines far more diamonds than they actually sell. Why don't they sell all their diamonds? Because if they did, diamonds would become commonplace and the price would fall. So De Beers restricts the supply of diamonds in order to maintain a high cost, or to maintain a high price. So again, characteristics of a monopoly: single seller, a unique product, a price setter. And the monopolist can set price, though again, there's a trade off between price and the quantity they can sell. And a final important characteristic is no entry into the market. Not anyone can go out and open up a diamond mine. There's some barrier to entry. Okay, in this case, the barrier is you have to physically own a piece of land that has diamonds under it. Competitive markets and monopolies are two extremes. Competitive market, whole bunch of sellers of a perfectly identical product. Monopoly, exactly one seller of a completely unique product. Most markets are, in fact, somewhere in between. And the next two models that I've mentioned here are markets that are, again, somewhere between competitive and monopoly. One is monopolistic competition. In a market with monopolistic competition, there are a few sellers, and the firms sell distinct, like unique goods, but they are somewhat similar and they compete with one another. So that might sound contradictory, but think, for example, of the market for smartphones. Apple sells smartphones, and Apple sells a unique product. Samsung also sells smartphones, and Samsung has a unique product. So those two smartphones are not perfectly identical. Okay, remember that's what happened in a competitive market, or that was a characteristic of a competitive market, was that firms were producing identical items. Monopolistic competition, they sell similar but unique items. Samsung Galaxies and Apple iPhones are similar in some ways, but they have their own unique features. Another example of monopolistic competition might be the fashion industry, where there are a handful of companies that each produce similar clothing, or they all compete in the clothing market, but each has their own distinct style. So Gucci and Versace and Ralph Lauren, they all produce clothing and they compete in the clothing market, but they have their own unique products. Yet another example of monopolistic competition might be universities. Um, each university has its own product, and universities offer similar goods. They all offer university education, but each of the universities is different. Elon essentially has a monopoly on selling an Elon education. And Duke University has a monopoly on selling Duke. And the University of North Carolina has a monopoly on selling University of North Carolina education. So they all have distinct products, and in some ways they are each a monopolist in their own area, but they compete with each other. Okay, so monopolistic competition has a few sellers of similar but distinct products. These firms can set their own prices, but they recognize that consumers are sensitive to prices and might go to their competitors if they set the price high. In part, what they do is compete with the other firms based on price, but also in part based on being unique, based on the features they offer. And so, you know, I think of monopolistic competition as the firms have this choice. If they want to win over customers, they could either cut their price, which does attract more customers, but at the same time cuts into their revenues. Alternatively, to attract more customers, they could add more unique features to attract customers. And maybe you can see how that's similar to what universities do. When they compete for students, they try to offer a unique package of amenities, types of learning, courses, location. Um, And they would rather compete based on features instead of cutting their price in order to attract more customers. Okay, so again, monopolistic competition, the firms are price setters, but there is a trade off with price. And finally, there's free entry and exit into the market in the long run.
An oligopoly is another type of market that is between a monopoly and a competitive market. An oligopoly is a market with a few producers. The first part of this word, oligo, that also shows up in the word oligarchy, which is government by a few people. Oligo means a few. So an oligopoly is a market with a few sellers. Okay, so as I've noted here, an oligopoly has a few sellers of an identical product. The airline industry might be a good example of an oligopoly because there are several airlines that'll fly people from point A to point B, and the flights for the most part are the same product. There's not a great deal of difference from one airline carrier to another. So we have a few sellers of these tickets, essentially an identical product in the airline industry. Now, a couple other things here. There might be barriers to entering or exiting the market, or there might be other reasons why an oligopoly naturally forms. Also, when we come to oligopoly, I'll talk about whether they are price setters. Okay, so first, let's talk about behavior of firms. Economists have a very simple view of what firms do. Firms convert some inputs into an output. So, for example, a bakery is a firm that converts wheat and water and labor into bread. Okay, so we have this very simple view. Inputs go in, output comes out. And for the most part, we ignore what happens inside the firm, what type of technology the firm uses, the exact production process is. That's not part of our economic analysis right here. In our simple view of firms, firms have a single objective to maximize profit. Firms do not exist to perform charity actions. Firms do not try and make the world a better place. Firms have one goal, which is to make as much profit as they can for their owners. Okay, so the definition of profit is the difference between total revenue, which is the money the firm brings in, and total cost, which is the money that the firm has to pay out. To put this another way, total revenue is price times quantity. So if the firm sells 1,000 widgets at $3 a piece, the total revenue that it receives is $3,000. And then the other part of this minus total cost. And I'll talk more about those costs in just a few minutes. Okay, so again, I want to emphasize the main goal of a firm is maximizing profit. This cute little drawing shows some of the important parts of the production process. Inputs go in, and some important inputs include the labor of the workers and capital. Capital is just kind of a generic term for all the things that the company needed to purchase in order to start the business, things aside from materials. And for the most part, capital are things that are not used up in production. So economists think of things like the physical building is capital, the machinery inside the building is capital, even the knowledge or information technology that the firm uses, those are forms of capital. And maybe it's important to think of labor and capital as the two primary inputs into production. Typically, the people who provide the capital are the business owners, and they are entitled to the profits of the firm. Okay, so I'm going to start with an example of what we call a production function, which links the amount of input into the firm to the amount of output it gets. So here in my hypothetical widget factory, I have this table that shows employing one worker could result in producing 100 widgets. If the firm were to employ 2 workers, the workers would produce 190 widgets. 3 workers, 270 widgets, and so forth. So again, we call this a production function.
I'd like to add a new column to this table for the marginal product of each worker. The marginal product is the increase in output when the firm employs this worker. Or maybe to make things simpler, the amount of output this worker produces. So again, that's called the marginal. Remember, the term marginal means a small change, a small incremental change. So in this case, it's the change in output for an extra worker. Here's how much each additional worker contributes to productivity. With no workers, the firm produces nothing. So the first worker increases the total product at the firm to 100 widgets. So with this worker, output has increased by 100 widgets. The second worker causes output to go from 100 to 190 widgets. So we say that the marginal product of the second worker is 90. The marginal product of the third worker is 80. In other words, the third worker causes output to increase by 80 from 190 to 270. By the way, it is important for you all to understand how to calculate marginal product of each worker. And it's very simple. It's the change in output when the firm added this worker. When the firm added the fifth worker, output changed from 340 to 400. So output increased by 60 when the firm added the fifth worker. I'd like to point out that for this production function, each worker contributes less than the worker before them. In other words, the fifth worker adds 60 to the output of the firm. The worker before that added 70. And the worker before that added 80. So again, each additional worker contributes less than the workers before.
We call that diminishing marginal product. Okay, again, formally, I would define that as each additional input contributes less than the one before it. Each additional worker produces fewer widgets than the worker before. And there are several reasons why we might expect that this normally happens at firms. Okay, maybe not always, but typically we expect that firms have diminishing marginal product. One is that workers might be sorted by productivity. In other words, there might be one person in the world who can produce 90 widgets, another who can produce 70 widgets, another who can produce 80, another who can produce 100. Then, if I, as an employer, am deciding which workers to hire, the first person I will employ is the most productive one, the person who produces 100. So, first worker produces 100 units of output. Then if I need to add a second worker, I go to the next most productive worker. That person produces 90. Then the third most productive worker, who adds 80 units of output, and so forth. So it could simply be that if there are differences in the workers' productivity, naturally, the first workers I employ will be the most productive ones, and I keep going down the list. So each worker, if I sort them by productivity, each worker I employ will be less productive than the one before. Um, Another reason why we might expect diminishing marginal product is that production gets less efficient the more workers we have.
As an example, Think of the problem of congestion if there were a handful of people who are all trying to do their work at one table. Okay, so in the beginning, the table is empty. The first worker sits down, starts assembling widgets. Then a second worker comes to the table and tries to assemble widgets. There's probably plenty of room for both of them at the table. Then the third person comes and they have to sort of set their stuff aside, keep their stuff separate. A fourth person comes, the table gets more crowded. A fifth, sixth, seventh come. And the more people who come to the table, the less efficient they are at doing their jobs because they're getting into each other's way. That type of situation might be representative of congestion problems that the firm faces with other resources, whether it's equipment that a firm has that uses in physically manufacturing something, or one supervisor has a limited amount of time to assist the subordinates, or there are a handful of salespeople who are all trying to find clients. The more salespeople that are added to the firm, the more congested they get. In other words, one person can easily find clients. Second person can pick up a few more clients. The third, a handful more. But there are fewer and fewer possible clients available, and each additional salesperson can find fewer and fewer. This is an important concept in economics. Firms typically have diminishing marginal product. Again, that means that each additional input contributes less than the one before it. If that were not the case, then we would see most industries just collapse into a single firm. Let's return to that table showing the production function and the marginal product of each worker. Suppose that this firm is trying to make a decision about the number of workers to employ in order to maximize profits. For this example, imagine that the widgets the firm produces sell for $1 a piece, and each worker employed costs the firm $75. For example, if the firm employs 2 workers, they produce 190 widgets. Widgets sell for $1 a piece, so the firm gets $190 of revenue from them. Then the firm has to pay $75 for each worker employed. So it employed 2 workers, it pays $150 in costs. That leaves the firm with $40 of profit, $190 of revenue minus $150 paid to workers is $40 of profit. Okay, if widgets sell for $1 a piece, and if workers need to be paid $75 each, how many workers should the firm employ in order to maximize profits? I said early in the course, or actually Greg Mankiw says in the textbook, that rational people think at the margin. And one way that the firm could approach this problem is to think about the marginal revenue brought by each worker compared to the marginal cost, the additional cost of each worker. The firm would employ a worker if the worker brings in more revenue than the cost of employing that worker. For example, the first worker produces an extra 100 widgets for the firm, which results in an extra $100 of revenue for the firm. That's the marginal revenue from employing the first worker. The cost of this worker, $75. So the revenue from the first worker is greater than the cost. So yeah, it's a good idea to employ this worker. Second worker increases production by 90 widgets. That means that the second worker increases the firm's revenues by $90, and it costs $75 to employ that second worker. So, again, it's profitable to employ the second worker. The worker brings in more revenue. than the extra cost of the worker. All of this is about the extra revenue of the worker versus the extra cost of the worker. Using the formal economics jargon, that extra revenue brought in by the worker is the marginal revenue of the worker. The extra cost of employing another worker is the marginal cost of the worker. So for the third worker, marginal revenue is $80. Marginal cost is $75. It's profitable to employ that third worker, but not the fourth. The fourth worker brings in $70 of revenue and costs $75 to employ. So the firm would lose money by employing that fourth worker. So that's not a good idea, nor is the fifth, nor is the sixth. So if the firm wants to maximize profit, it can think worker by worker. Is it profitable to employ the first worker? Is it profitable to employ the second worker, the third worker, the fourth worker, and so on? Okay, that's the idea of thinking at the margin, just thinking for each extra worker, does the worker bring in more revenue than the cost? In fact, this is essentially the question the firm asks itself every time it makes a decision. Is the marginal revenue greater than the marginal cost? Almost all of the profit maximizing decisions of a firm that we discuss boil down to that. Is marginal revenue greater than marginal cost? If so, it's profitable. Do it. Okay, now I'm going to switch topics a little bit. I'm going to talk about costs. First, I'm going to give two different definitions of costs. One is the way that a normal person thinks of costs, which we call accounting costs. The other is the way that an economist thinks of costs. Okay, so accounting costs are the money or the monetary transactions in order to use a good. We also use, and I'm sorry this is so confusing, we also use the term explicit costs to refer to these because they are clear. That's what the word explicit means. These are clearly costs that the firm pays. There is a monetary transaction. But an economist defines costs differently. To an economist, the cost of something is what you give up in order to use it. Remember, that was again one of Mankiw's principles at the start of the course. The cost of something is what you give up in order to use it. So, I give as an example the cost of going to a movie. I paid $10 for a movie ticket, but I also have to give up 2 hours of my time to watch the movie. And if time has value to me, the cost of watching the movie is not simply the price of the ticket, but also whatever else I give up with my time. Okay, so going to the firm, the costs of using inputs into production include the explicit costs when the firm has to actually pay money in order to acquire some input. But also, costs include the value of the alternative use of some of the resources that the firm uses. Some of the resources that the firm owns. I think, for example, of a farmer who plants the farmer's own field and raises a crop using the farmer's own labor. The farmer might not recognize that there is a cost to using the farmer's own field and a cost to using the farmer's own labor. It might seem there's no cost because the farmer doesn't write themselves a check to rent their own land from themselves. They don't write a paycheck to themselves for the labor that they employ from themselves. They don't write checks. They don't have explicit, clear costs. But there is a cost of using their own labor. They give up time that they could have used for something else. Maybe this farmer could have used that time instead to work a second job, earning money in that other job that paid $15 an hour. Then, for each hour that the farmer works on their own land, growing their own crop, they are giving up $15 of income that they would have had from another source. That's the cost of using their own labor. Similarly, there's the cost of using their own land. Farmers will rent land from each other, maybe from a neighbor to plant a crop or to graze some cattle. They'll rent land to each other, they'll rent from one another. The farmer might think there's no cost of using the farmer's own field in the way that the farmer would have to pay someone else to use that other person's field. Okay? Paying the other person is an explicit cost, but an economist would say using the farmer's own land is also a cost, and it's the same cost, more or less. The farmer is giving up the opportunity to rent out their field to someone else for money. So this farmer could have rented out the field for $1,000. By using the field to raise their own crop, they are giving up $1,000 of rental income. And that is, to an economist, a real cost. We call these costs that are not monetary transactions, we call them implicit costs. And I've labeled here like one type of implicit cost are opportunity costs, the value of the alternative use of these resources. Another type of implicit cost is paying profit to the owners of the business. Now, this is a little bit tricky and confusing. There's a difference between what an economist calls profit and what an accountant calls profit. In both cases, it's the difference between revenue and cost. But an economist believes that a cost of using the owner's capital is that the firm must provide a certain amount of profit to the owner. And that amount of profit is called a normal return. So, what an accountant would think of as profit, maybe you can divide that into the two parts. Part is simply the normal return, which is matching what the owners could have received if they would have invested their money in something else. So, for example, if starting this business requires $1,000 of capital, and the owners could instead have put that money into a bank account that generated 5% interest, in other words, $50, then a normal return in this business would be $50 of profit. If the business generates more profit than that, that extra return is considered profit by an economist, but the normal return is a cost of doing business. A cost of doing business, an implicit cost. The firm needs to be able to provide that normal return in order to keep the owners happy and to keep the firm running. Okay, any extra return is an economic profit. So if this business generates $80 of profit, the money to match the bank account, that $50, that is an implicit cost. The extra $30 is economic profit. Now let me divide costs into two types. Some costs are fixed costs. These are things that the firm needs to pay for regardless of how much it produces. So a fixed cost might be the cost of building a factory or renting a shop or getting licensed to do business. All of those things are costs the firm pays that have nothing to do with how much the firm produces. A variable cost is one that depends on how much the firm produces. For example, at a restaurant, the cost of the ingredients used to prepare meals are variable costs. They depend on how many meals are produced. The cost of labor, wait staff, cooks, those also depend on how much the restaurant produces. Those are variable costs. Finally, I'll put down here that fixed costs and variable costs together, those are all the costs. So this means a couple of things. One is simply that all costs can be classified as either a fixed cost or a variable cost. The other thing is to remember mathematically when we use the terms fixed cost and variable cost, those do always add up to total cost. Okay, you're going to need to recognize the following types of costs. As I just said, fixed costs and variable costs, the total cost, which is the sum of those two, and then the averages of total cost, fixed cost, average variable cost. And these will often be abbreviated. So just recognize that when you see an abbreviation and the last letter is C, it's referring to cost. TC for total cost, FC for fixed cost, VC for variable cost, ATC for average total cost, AFC for average fixed cost, AVC for average variable cost. If you see an abbreviation and the last letter is a C, it's referring to a cost. If the first letter in the abbreviation is an A, it stands for average. And if the first letter in the abbreviation is an M, it is marginal. Okay, so MC, marginal cost. This is the most important cost, really. The marginal cost, remember, marginal means a small incremental change. So the marginal cost is the additional cost from producing another unit of output. Okay, the increase in cost when the firm produces another unit of output. In the examples we use in class, we will often start with a cost function for a firm. A cost function relates the amount of output to the total cost of the firm. So this firm, the owners or someone has sat down and figured that if the firm produces one widget, they've added up the cost of the workers, the materials, the factory, and it would come to a total of $150 to produce one widget. To produce 4 widgets, they've priced that out. The firm could produce 4 widgets for $360. And up here at the top, 0 widgets would cost $100. In other words, that $100 is the fixed cost for the firm. It pays that cost regardless of how much it produces. Let me expand this table to include the other types of costs. As I said, the cost of producing nothing is $100, so that's a fixed cost. The fixed cost is the same regardless of how much the firm produces, so I can just carry that down the column. No matter how much it produces, there is a fixed cost of $100. By the way, you should be accustomed to working with these tables for questions on tests or other assignments. If you are given simply the cost function for the firm, that means the quantity of output and the total costs, you should be able to complete the rest of this table. Okay. So next column, variable cost. The variable cost is 0 when the firm produces nothing. Remember, the variable costs are the ones that depend on how much the firm produces. It's the difference between the total cost and the fixed cost. So this firm has $100 fixed cost. That implies that when it produces 1 unit of output, the $150 cost, 100 of that is the fixed cost, the remaining 50 is the variable cost. When producing 2 widgets, total cost is $210. We know that the firm has a $100 fixed cost, and so then the remaining $110 are the variable cost. Okay, I'm going to add now a column for marginal cost. The marginal cost is how much the firm's costs increase from producing this widget. Going from producing nothing to producing 1 widget, the firm's costs increased from 100 to 150. So, in other words, this first widget increased the firm's costs by $50. Producing the second widget increased the firm's costs by $60. So we say that the marginal cost of the second widget is $60. The marginal cost of the third widget is $70. In other words, producing the third widget increased the firm's costs by $70 from 210 to 280. One thing I'd like to note here is that there are increasing marginal costs for this cost function. This is kind of the flip side of what I discussed earlier, diminishing marginal product. Diminishing marginal product was the idea that each additional worker, for example, produced fewer widgets than the worker before it. That was diminishing marginal product. Diminishing marginal cost means that each widget costs more to produce than the one before it. So the first widget cost $50 to produce, the second widget cost $60 to produce, the third $70 to produce. I'll come back to this later on, but typically economists expect that firms have increasing marginal costs. The final thing that we might calculate for this table is the average total cost. Average total cost is the total cost divided by the number produced. So when producing 1 widget, the average total cost is 150 divided by 1, 150. When producing 2 widgets, total cost is 210. So 210 divided by 2 is an average total cost of $105. When producing 4 widgets, total costs are $360. So the average total cost is $90. Let me return to the topic of increasing marginal costs. Again, we usually expect that the marginal cost of production will increase. Each extra widget will cost more to produce than the ones before it. There are a couple of reasons why we would expect this. One is diminishing marginal product. Imagine that the workers who produce widgets are less and less productive. There's one worker who can produce a widget entirely on his own, a couple of workers who can each produce half of a widget, a few more who can each produce a third of a widget, then some who can produce a quarter of a widget. This means that the firm can produce the first widget using only one worker and paying the salary of one worker. The second widget requires employing 2 workers and paying the salaries of 2 workers, so the costs are higher. The third widget requires employing 3 workers and paying 3 workers' salaries, so again the costs are yet higher. Every additional widget requires employing less productive workers, but more of the workers, and so paying a higher number of workers translates into a higher cost of each subsequent widget. Okay, so that's one reason why economists would expect typically firms have increasing marginal cost. It's because the marginal product diminishes. Another reason why firms would typically have increasing marginal costs is that the cost of inputs increases. The farmer who's planning on planting fields for crops might be able to rent one field from a neighbor for $600. Another neighbor is willing to rent a field for $400. A third willing to rent a field for $1,000. Well, that farmer will first rent the cheapest field for $400. If the farmer needs to plant a second field, the farmer goes to the second cheapest field, $600. A third field would cost $1,000 to rent. So the marginal cost is increasing because the cost of the inputs is increasing. There are a variety of other reasons as well. The next topic is whether a firm operates more efficiently when it's small or large. This is a matter of scale, whether the firm operates at lower average total cost when the firm is producing a small quantity, a small scale operation, or producing a large quantity, like a large scale operation. We used the phrase economy of scale for a firm that operates at lower average total cost when it increases its output. Formally, the definition of economy of scale is that increasing the output of the firm in times, that can be any number, increasing the output in times increases the costs by less than in times. For example, when the firm doubles its output, the costs less than double. Economies of scale are fairly uncommon. In some industries, they might happen because of high fixed costs of production, or lots of specialization, or sometimes network effects. One industry that seems to operate more efficiently at large scale might be the hospital industry. My understanding is that for a hospital to operate, it requires a complex administration to handle things like insurance billing. It's very complicated for a hospital to know how much different insurance companies will pay for different procedures, and so it needs a team of experts who can handle processing the insurance claims for all the different insurance companies. For a small hospital, this is very expensive, having that team of people who can handle the insurance claims. A small hospital then doesn't operate very efficiently if it has to employ a large, expensive team of people to handle all the different types of insurance claims. If two small hospitals were to merge, they could use the same billing department to handle these insurance claims. So they don't each need their own billing department. So when the two hospitals merge, they can double the number of patients they produce. Surgical procedures they produce for patients. They can double their output, but since they don't need quite as much overhead administration, the cost's less than double. Typically, when an industry does have economies of scale, the industry collapses into just a handful of very large firms. And that's certainly what we see in the hospital industry. Hospitals are repeatedly merging until just a handful of large healthcare organizations run most hospitals in the US. Another example of economy of scale might be the airline industry. The airline industry has a funny network system. As I said, network effects can sometimes result in economies of scale. Imagine that an airline purchases one airplane. It can then take passengers back and forth between city A and city B. Then, if the airline purchases a second airplane, it can take passengers between A and B as well as between A and C, but this means it also serves passengers traveling from B to C with a change at A. So, doubling the number of airplanes triples the number of cities that it can serve. Buying a third airplane, the airline can take passengers between A and B, between A and C, between A and D, as well as between D and C, D and B, uh, C and B. So with three airplanes, it can serve 6 cities, and it keeps increasing and increasing. The fourth airplane would bring the number of routes that the airline can fly up to 10. If each additional airplane can add more routes to what the airline produces, then flipping that around, each extra route costs fewer airplanes that the airline needs to purchase. And if you look at this picture I've drawn, you'll recognize this is kind of the hub and spoke model that airlines use. You're familiar with almost always flying from two places, from B to D. You need to change airplanes at one of the airline's hubs. The reason that airlines use this model is taking advantage of this network and the fact that they can increase the number of destinations they serve or routes that they fly more cheaply. It's a This network effect causes a type of economy of scale, and as I said just a moment ago, typically when there are economies of scale in an industry, we see that the industry collapses into only a handful of large firms. But more often, industries have diseconomies of scale, which means that scaling up production by a factor of n times causes costs to increase more than n times. For example, doubling the output of the firm more than doubles its costs. Think, for example, of a business that operates with franchises, identical stores in multiple locations. To go from one store to two stores, the cost of the store itself is the same, but then the company needs to add a supervisor who looks out over both stores. So that administration that looks out over both stores is a new cost when the business doubles in size, costs more than double. Another reason why we expect that most industries have diseconomies of scale is simply increasing marginal costs, would imply that each increase in output costs more than the increase before it. Now, I want to talk about a firm maximizing profits, picking the amount of output to maximize profits. Suppose a company has figured out this is what it would cost to produce 0 widgets, 1 widget, 2 widgets, and so forth. And suppose that the price the company can sell the widgets for is $11 a piece. The company wants to decide how many widgets it should produce in order to maximize profits. There are a couple of approaches we could take to this problem. One method involves calculating the revenue for each level of output, so the amount of revenue the firm gets when it produces 0 widgets, 1 widget, 2 widget, and so forth, and then the amount of profit that it yields from producing 0 widgets, 1 widget, 2 widgets. And then we identify what quantity of output yields the most profit. Using this method, the first step is to calculate the total revenue from selling 0 widgets, 1 widget, 2 widgets, and so forth. Total revenue is price times quantity. If the firm sells 3 widgets, quantity equals 3, at a price of $11 a piece, price equals 11, then the total revenue is $33. So I filled in this total revenue column. Selling 0 widgets, the firm gets $0 of revenue. 1 widget, $11 of revenue. 2 widgets, $22. 3 widgets, $33, and so forth. The next step is to calculate the profit from each level of output. Profit is the difference between total revenue and total cost. So when the firm produces 0 widgets, revenue is 0, cost is 10, the profit of the firm is negative $10. In other words, the firm has a $10 loss. Producing 1 widget, the revenue is $11, the cost is $12, profit is a loss of $1. Producing 2 widgets, the firm's profits are $22 of revenue minus $16 of cost equals $6 of profit. And so I continue down and calculate the profit the firm would get from producing each level of output, from producing 1, 2, 3, 4, 5, 6. Then in the final step, I identify how much output maximizes profits. This firm can get the most profit if it produces 5 widgets. That yields $15 of profit. So I've written here Q star equals 5. But there's going to be another technique, a shortcut to doing all these calculations. Remember that I said earlier, the question for firms always, when maximizing profits, the firm can simply ask, is the marginal revenue from something greater than the marginal cost? And if so, the firm should do it. Let's suppose the firm takes that approach to deciding the output. Let me call this method number 2. Really, in truth, it's the only method that economists think about. First, calculate each marginal cost, the marginal cost of the first widget, of the second widget, and so forth. And then the firm should decide to produce that if the marginal revenue is greater than the marginal cost. Produce the second widget, for example, if the marginal revenue is greater than the marginal cost. Here are those marginal costs. The first widget increases the costs of production by $2. Increases the cost of production from $10 to $12, so increases total cost by $2. Second widget increases costs from $12 to $16. In other words, it increases costs by $4. The third widget costs an extra $6. Fourth widget adds $8 to the costs. So here are the marginal revenues from producing the first, second, third, and so forth. The extra revenue from producing each widget is $11, what the firm can sell the widget for. So the firm then can think about the marginal revenue from each widget versus the marginal cost. Producing the first widget brings in $11 of revenue and costs $2. Is marginal revenue greater than marginal cost? Yes. $11 of revenue versus $2 of cost, it makes sense to do that. Second widget would bring in $11 of revenue and add $4 to the costs. Again, it's profitable to produce that. Brings in $11 of revenue, adds $4 to the cost, so it contributes an extra $7 to profit. The third widget brings in $11 of revenue, costs $6 to produce. Again, it's profitable. And the firm goes down this list deciding which widgets are profitable to produce. The last one that's profitable is the fifth widget. The fifth widget brought in $11 of revenue. It added $10 to the costs, so it was profitable, but not the sixth widget. The sixth widget would add $12 to costs and bring in only $11 of revenue, so the firm would not want to produce that. In order to maximize profits, This firm should produce the first 5 widgets and then stop. In other words, the profit maximizing quantity is 5. This second technique brings us to the same conclusion as the first. 5 widgets is the optimal amount to produce. Here I'm demonstrating again how a rational person can think at the margin. You'll see this approach used a lot when we analyze particular markets, like a competitive market or a monopoly market, which are the next few lessons. But that's all for this topic for now.